Okay, so this is the video tutorial on how to do k-means clustering using Orange software. And I have a fresh slate of Orange opened here. New workflow. CSV file import. The file that we are going to be using is on Canvas. It is the tutorial k-means salary, which is the same one I used for the distance measurement tutorial. Even though that one goes along with this. So yeah, there's kind of a lot of exercises this week, but they're not like super duper hard. And there's nothing project due, so you should be okay. So the first thing that you did is you did the distance and normalization, then the hierarchical clustering, and then this video is going to be the k-means, and that's all the clustering techniques, and then you have some exercises and stuff to do. So we are going to open our data that we're going to use, which is the tutorial k-means salary. That is, yours is on Canvas, mine is here. So tutorial k-means salary, open sesame. It already, now I don't really quite know why this is, but because I've used it earlier for the previous tutorial, it actually has the data types in. But remember that when you do a CSV import, you have to set the data type. So set these to numeric. I really have no idea why it's sensing that those are already there, because I closed out and I'm restarting Orange entirely, and that was a couple hours ago when I did the other video, so whatever. So now the data is loaded, but for what we want to do with this is we want to actually do the k-means clustering. However, before I do that, I need to normalize the data, which I'm going to do with preprocessing. And yes, this is exactly what we did. We normalized it before. So I want to run this through here. And I want to do normalize features, standardize. That's perfect. And it's always good to check the data, even though I know that if you watch the other video, we did the same exact thing earlier. So look at the data after pre-processing. Just make sure it's normalized and looks like it should. It's not on the regular scale anymore. Okay. So now what I actually want to do is I want to actually do my k-means clustering. The widget for k-means clustering is under unsupervised. This should come with, this is part of base Orange, so you don't need to install anything. It should be there. It's this right here, this little k-means. These are supposed to be clusters. They don't really look that clustery, but they are. So you can send the data. You can actually send this from the data table, or oops, I always do that. Like Orange is a little slow, and then I like double click, and then I have two of them. So you can either run it from the data table or from preprocess. I'm just gonna run it from preprocess. Okay. And then click on this. Okay. Now, what we actually want to know first is how many clusters, and the answer is I don't know. And the other answer is that I want silhouette scores, and double click on this to see the silhouette scores, and they're not there, and they should be, which is real. Oh, click on this. There we go. So the way that you get the silhouette scores, remember that the silhouette scores essentially tell you how many clusters. The other way to do this is with a scree plot. But as far as I can tell, like you can get the scree plots when you do principal components, but you don't see them in k-means in Orange. So I'm going to use the silhouette scores to determine the number of clusters. Now, this is a little tricky. So click on k-means, and then this, initially it was fixed to 3. I don't know why. That's actually the correct answer for this data, but I don't know if that's just default or how that's set. So click this, and generally speaking, cluster analysis, you want at least 2 clusters and maybe up to 8. So it's actually calculating the silhouette scores for various numbers of clusters. And what you want to do is find the maximum one, which is 3. So 3 is the number of clusters that we want to use. These other settings you could sort of goof around with, but remember how this works. K-means clustering, you set the number of clusters, which is going to be 3 in this case, and you run the algorithm, and what it's doing is it's randomly assigning 3 means, and then it's taking the data and finding the data that's closest to each of those centroid means and then it's reassorting, and then it's reassigning, and it iterates until it stabilizes, and that's how you form your 3 clusters. There's actually a simulation of this that if I can, I'll show you. So that's the k-means clustering, and then the only other thing to do from here is to actually graph it. So literally run the k-means by setting it equal 3, and then just look at a scatter plot. Okay. So scatter plot this by going under visualize. Again, I have a bunch of stuff on my orange that you probably don't because I played with a lot of stuff. So go to scatter plot and here. And then we can visualize. Oh. Maybe we can't. I don't know. Oh, this is like doing stuff from previous scatter plots. Interesting. So this is the scatter plot, and I had to uncheck all of these. So we see here, this is the age and salary data. Okay. And we could also scatter plot this without the annotation. So cluster 1, cluster 2, cluster 3, it's grouping the data by clusters, which is very, very nice. Yeah, so this is the standardized data, and we have 3 clusters of age and salary groups. We have this one, this one, and this one. The original data, if you look at it, and in this case, you want to go back to the original data because the normalized data is going to be hard to determine. So if you very carefully look at this data, there's sort of 3 groupings of like older people, which are the 70 and 88-year-olds, and salaries, and like 20-somethings and then 40-somethings. And so that's kind of the 3 clusters we're looking at. So that is the basics of k-means clustering. But you can also get the values of the centroids, which is actually, this doesn't show the centroid because it's a scatter plot, but the centroid would be the center of these, and then that's where it's stabilized. Okay, so you can get the centroids and the annotated data. So let's do that. And you can get that from this k-means. So I want to create 2 data tables from this. 1 and then 2. Okay. Let's do for the first one, let's do the annotated data. I always do that. Okay. And so I'm going to flow the results of k-means into this data table. Now be careful because this, I want data to data. I don't want centroids now. When I double click on this, this is the data, obs 1 to 10, and the clusters that they're assigned to. Now this is on the normalized data, so you actually have to go back to the original data. Like row 2 is 20 and $40,000 a year, age 20 and $40,000 a year. So you have to go back and forth the data to interpret this. So here, so like these are actually row 1 to 10, even though, because for some reason, orange seems to always put the variables in row 1 when really they're just variables. So row 10 is cluster 2. So 10 and 11 are this cluster 2, which is this right here. These are the older people because their age is above the standard deviation. So these are the older people that are making lower salaries because they're working probably like sort of retired people kind of jobs. And then we have like cluster 3 is actually the first 3 in the data. I lost my original data somehow. Oh no, here it is. So cluster 3 is the first 3. So those are sort of like the 20-something people. It should actually be the first 4. Let me see that. It is the first 4. So the first 4, if you look at the data, like these 4, I'm trying to not get it to select columns and select rows, but I don't know if I can actually do that with this. So the first 4, these people in their 20s, this is your first cluster. And then the second cluster is the people in their 30s and 40s, and the third cluster is the people in their 70s. And so that's actually what you're seeing when you have this, is the 3 clusters of sort of like young people. These are the young people. And the people that are making the most money are like the 30, 40 something. These are the people in like this high cluster because this is the salary they're making above average. the young people aren't making so much money, the old people aren't making so much money, but the middle-aged people are. And so we're getting from k-means clustering a nice clear clustering, which the data is actually pretty clear in clustering. So that is an example of k-means clustering. That's the annotated data. You can also get this right here. And I'm going to do the second data table. And what I'm going to do is I'm going to export the centroids. So I'm going to do this, but be careful here. You want to change this and you want to do centroids. The clear all seems to work better for me than clicking on things. So that, the centroids. And so this is going to be the centroids, which for each cluster, these are the center points of them. Okay. And right here. Okay. So these are the coordinates of each centroid. So for cluster 1, this would be helpful if I had the this. There we go. Nice. Okay. So for cluster 1, the centroid is age 0.6 and salary 1.7. So you can see, or 1.17. So right here is like the 1.17. So this right here is like, there's not actually a point there, but this is where the centroid would be for that cluster. And that's what these are given. Okay. Same thing with this one down here. That would be cluster 2, and it's, or that would be cluster 3, and it's like negative 0.9 on the age, because these are the younger people, so that would be like down here. And that's how that works. So you can actually get the values for the clusters. I mean, the centroids of the clusters, which is nice to have. One more thing I'm going to show you, because this kind of like solidifies what k-means is doing. You don't have to install this. I'm just gonna, this is just there's no homework on this. This is just something I'm gonna show you. So I'm loading the data again into another workflow, and there is this, basically it's a demo thing. So there's this education wizard. Now I do want to normalize this. I do want to normalize it again. I know I already did this in the other one, but I'm gonna do it again. So I'm gonna pre-process just to get standardized values. And I'm going to normalize this. Okay. Standardize, good. Now what I'm going to do though is I'm going to use this education like demo wizard thing. Under educational, these are things that I think were just developed for demonstration. Like you wouldn't actually use these for analysis. They're just for teaching purposes. So you don't have to do this, but I just want to show what goes on with the k-means. So I'm going to flow the normalized data into k-means, into this interactive k-means. This is not the same as the one that we actually use for actually doing the analysis. This is like a little simulation thing. So I'm loading the normalized data in here. Okay, so make sure it was recording. And, okay. So I'm going to double click on this. Now this is almost kind of like a video game. So we have age and salary, which this is the same as the other one. This is actually, there's already centroids on here. So what Orange did, what the simulation did is, this is the same exact data we looked at before. That was like, with the cluster labels that we just looked at. So this is the like old people making not a lot of money. This is the young people making not a lot of money. And this is like the middle-aged people who do make more money. These squares are the centroids. Now what Orange did and what k-means does in general, because we want 3 clusters, so it stuck 3 centroids on here sort of at random. You can just recompute centroids and it will just literally stick, it will stick centroids on here. And every time you do it, you will not get the same results if you do this every time because they're random, or they should be. I don't know, maybe they don't come out random. So here, they look a little different than last time. So what it's initially doing is it's assigning these 3 to this centroid and these 3 to this centroid, which actually turns out to be the right clustering. But if you run this and run the simulation, you can, these are actually, what it did is recompute centroids, step back. Let me actually start this again, run it step by step. Okay. Oh, bummer. Wait. Okay, so okay. If I this is, again, there's new random centroids. These are not the same as last ones. So if I do this, watch. Iteration 1, iteration 2, iteration 3, and at this point it's stabilized. So did you see that? Let me do that again. Okay, so this is where it started. I don't know why there's a voice thing there. I don't know what that's doing. Okay, so this is the initialization. It's initializing these 3 centroids. Then I do recompute centroids, because what it's going to do is it mapped the distance of these points and determined this is the closest centroid here, this is the closest centroid here. Now, in this case, this is actually not how you want them clustered. So we're going to recompute the centroids, and the centroid is going to move to the center of this. See that? Next, it's going to reassign the points to the centroid they're closest to. So this one here is going to go along with that. These others are okay. So it's going to reassign the membership. See that? Now it has a reassigned membership, so we have to recompute the centroid again, because this one was reassigned there. This is no longer the centroid of this, nor is this one. So recompute the centroids. Okay. So now these are pretty close to done. Reassign membership. These might move a little, but probably not a lot. And then recompute centroids. And then at this point, I think we're stabilized, and then because nothing's moving anymore. So that's what k-means clustering is doing, and I want to show that because it kind of solidifies what's going on here. But otherwise, k-means is fairly simple. So you run through, load the data, normalize the data, use the k-means silhouette feature. Don't forget that you have to change that. I think I still have this one up. So don't forget that on here, on this k-means, you have to change this to see those silhouette scores. I don't know whether it's just defaulting to 3 or it actually sends that 3 is the number of clusters to use for this data. I don't know. But I would still go ahead and check that and then set the number of clusters. And then just run it, and you can see the clusters on a scatter plot. These are labeled. You have to fiddle with these to label them, but they'll get labeled. And then the data, this is the normalized data, but you can actually see the clusters mapped to the individual data points. And you can also actually get the coordinates of the clusters if you want them. Just to sort of you might want to use this just to check that your clusters are sensible, because k-means, it does start with a random, it starts with a random assignment of the centroid. So it's always not a bad idea to sort of look things over a little bit. Okay, so that was the tutorial on the k-means clustering, and your assignment again is on here, and there are 2 data sets for you to do, and then that is it for the clustering module. Yay! Enjoy.